Today's lesson is on equivalent decimals and comparing decimals to one another. And our standard is to identify decimals that name the same number or quantity, using place value to compare decimal quantities. So for today, you do not have any foldable piece in your notebook. We're just going to take notes with our pen. And just for your own personal preference, if you would like to follow the color coding that I am doing in my notes, it may be worth your while. I do make pretty specific choices about the colors that I'm using, so if you would like to do that as well, you're more than welcome. Let's start out with an example. The first example I want to talk about is a number called 1 and 6/10. And this number can be written many different ways. It can be written as exactly as it's said, which is 1 and 6/10. It can be written with 1 and 6/10, or it could be written 1 and 6/10. All these numbers are absolutely equal because they end in a 0. When we talk about numbers that are not decimals, sometimes we can write the number 5 or the number 5 or the number 5. And because they're numbers that are greater than 1, the zeros preceding the numbers make them all the same. However, when we talk about decimals, the zeros following the number also makes them all the same. There's no difference between 1 and 6/10 without any zeros as there would be with 20 zeros, okay? One piece of notation I want you to jot down is that this sign right here is a not equal sign, and that's something that we'll use throughout the notes today. So let's look at a couple examples. If I say 0.09 and we'll compare that to 0.009, our next example will be 7.2 compared to 7.20. And then we'll also look at 7.10 compared to 7.1. Now, these numbers are either alike or equal or not equal. The example A can be read 0.09 is 9/100ths. The second number in this system is 0.009, which is 9/1000ths. So these values are not equal. In example B, 7.2 is 7 and 2/10, and 7.20 is also 7 and 2/10. So those are equal. Letter C, the same scenario, 7 and 1/10 is equal to 7 and 1/10. Right? The zeros that follow our decimal don't change at all the value of what the decimal is actually worth. So just to make this very clear, 1.27 is the same as 1.270 is the same as 1.2700000, on and on forever, right? Next, we want to just think about comparing decimals. And whenever you compare decimals, you want to use either the equal to sign, which we've discussed, the not equal to sign, which we've discussed, or the greater than and less than signs. The way that I track my greater than and less than signs is I always pretend that it's a very, very hungry mouth, and that this hungry mouth wants to eat as much as it possibly can. So the mouth is always facing the larger of the number. So in this case, if I had a number here and a number here, the first number would be less than the second number. So this is my less than symbol. followed by my greater than symbol. So I'm going to continue my notes here and just review that the equal than symbol and the not equal to symbol are also important when we're comparing decimal values. A few examples that we can go over. We'll compare 0.16 to 0.28. You always want to start with the first number of the digit from left to right and think about which number is smaller. The first number here is 1 and the first number here is 2. So obviously the decimal value that begins with the 1 is less than the decimal value that begins with the 2. Again, we can do that again with 1.42 compared to 1.46. My first digit is equal, as is my second digit. The third digit, the 2, is less than the 6. So 1 and 42 hundredths is less than 1 and 46 hundredths. When you're trying to order numbers from least to greatest, you should also work with this method specifically. You may want to vertically align your digits. For example, when we're ordering decimals, I may have the values 2.655, 2.644, and 2.662. My first digits are all equal, as are my second digits. So the third set of digits is what I'm going to look at in order to order my decimal values. This is going to be the smallest, this is the second least, and this is the largest value. So if I wrote these out in ordered place, I would say 2.644, 2.655, and then 2.662. Ordering decimals can be tricky if you don't work with your place values, so please be patient and be careful in your organization of your decimal values. So here are all my notes completed so that you can see exactly what it looks like on my paper. However, you do have a proof to finish before you're done with your journal entry, and it asks you to place the numbers in order from least to greatest. There are 3 specific problems here to order, so I should see 3 different answers in your notebooks.